Hello all, welcome back to the 5-Minute Tech channel. Today we'll be talking about microservices event-driven architecture with RabbitMQ on Docker container. So we'll be talking about how the different services communicate to each other through RabbitMQ. On this area, the red highlighted area, which is the place wherein all these services communicate to each other through an event bus with a publisher-subscriber channel based on the RabbitMQ. In event-driven communication type, microservices do not call each other. Instead of that, they create events and also consume the events from the message broker, in this case, which is our RabbitMQ, and it's mostly in the asynchronous way. What are the positives of this kind of architecture is the producer service, the one which creates those services of the events, does not know about the consumers, and on the other hand the consumer do not know about the producer. As a result, the services can be deployed and maintained independently of each other. This is the key requirement which we have for microservices. So this full-fledged implementation assists in that decoupled microservices. The negative is that there is no clear centralized place for defining the whole flow, although we have certain areas where we define the way it will communicate, but there is no central orchestration. So what is RabbitMQ? RabbitMQ is a message queuing system similar to something which we have like an Apache Kafka, MSMQ, Zoo Service Bus. Kestrel is also an example, along with ActiveMQ. The purpose of this RabbitMQ is to transmit a message received from any source, producer in that case, to another source as soon as it is their turn. In other words, all transactions can be listed in a queue until the source can be transmitted gets up. RabbitMQ supports multiple operating systems. It could be in different operating systems, and it's also an open source which helps it has. So if you see the below image, we have the publisher which publishes to an exchange. It has the routes to the queue, and the queue is where the consumer goes and consumes those messages. This is the entire section. The middle section is the RabbitMQ area. So what is the entire logic of RabbitMQ? So RabbitMQ works in a pub-sub model, producer, consumer, and a queue. Producer is the source of the message in the application. So if you see here, the producer is the source which provides all the messages. The queue is where the messages are stored. So this is the entire section of queuing mechanism. The sent messages are put in a queue before they are received. All incoming messages are stored in the queue, that is the memory. Consumers in turn are the servers that meet the send messages. It is an application which will receive and process the messages. The data packet will be sent through the messages, which is called the message. And the exchange is the structure that decides which queue to send to the message. It actually decides according to the routing keys. And the bindings are something like a link between our exchanges and the queues. And this whole system follows a pattern called FIFO, that is FIFO, first in, first out, which is the basic principle of a queue. The order of processing the outgoing messages in our RabbitMQ is first in, first out. The producer project sends the message to be queued, and the message is received by the exchange interface, and it redirects to one or more queues according to the various rules that we have configured. Now, RabbitMQ exchange type, there are different ways in which this exchange can be configured. There is a direct exchange, we have topic exchanges, fan out exchange, and the header exchanges. Direct exchange is basically a routing key is determined according to the things to be done, and accordingly the most appropriate queue is reached and relevant direct messages are delivered. Topic messages have specific topics. Messages are sent to different queues according to their subject, and the incoming message is classified and sent to the related queue. The route is used to send the message to more than one queue depending upon how we want to handle it. The fan out exchange is something which we use in situation where the messages should be sent to more than one queue. There are multiple queues in which we have to send the messages, and it's like a broadcasting system. Example would be our gaming systems for global announcement and stuff like that. Header exchange is the least used, and it is guided by of the messages. The attribute on the header and attribute on the queue must match each other's value to be exchanged. Moving on, we also have something called as MassTransit that we'll be using in our system. It is an open source lightweight message bus framework for .NET. The MassTransit is useful for routing messages over MSMQ and our RabbitMQ and similar technology stacks. MassTransit also supports multicast, versioning, encryption, and other features. So our services, we will be using MassTransit as well for communicating the messages between the different microservices. So we will quickly move on to a demo part where we will just show how to get your RabbitMQ up and running. So for that purpose, we will run a couple of Docker commands, and so the first command is to pull the latest of the RabbitMQ. I'm here pulling an image called 3 management because that has more of a management built in. So you just need to pull that image. So as you see, I already have the latest image, so I will run the next command which will bring up the RabbitMQ instance. Actually run the instance. If you see, we are running on the port number 15672, so that is the one which we will be targeting through browser. So here my RabbitMQ instance is up now. I will go to the browser. So as you can see, I have launched the port 15672, and you can see we are able to see the connections, channels, exchanges, and queues. In our next part, we will be talking about how a shopping cart service interacts with the ordering services and gets the checkout done for the customers. Thanks for watching this video. Hope to see you in the next part. Have a nice day.